Hello everybody, my name is Dustin, as you already know. Today, I have created a new example inside of my coding language. This is what the code looks like. It kind of looks a little bit similar to what I've done in the past. Let me actually, no, that was in the right spot. What I've done here is create game of life inside of my programming language. Don't know what game of life is. Let me pull it up here.
It is lockdown where I live, and
Just a Wikipedia article. This is Conway's game of life. Cool little illustrations and whatnot for it. But I have done this in my language. I've coded the entire thing inside of my language. The only thing that is sort of written in a different language is this. I'm just passing this through straight to go, just so it's visible. You can actually feasibly see it. Other than that, everything else is in my language. So we're iterating through this 1,000 times just so we can get a full scope of what this program does. But in short, let me show you what this exactly is. Game of Life has a couple of rules, similar to Rule 110 or Rule 126, which I've shown in the past. Game of Life has rules as well, such as any live cell with 2 or 3 live neighbors survives. Any dead cell with 3 live neighbors becomes a live cell, and all other live or dead cells are dead. And this is easily translatable into my code by using left neighbor, right neighbor, top neighbor, bottom neighbor. And the way that this is kind of like illustrated in like ones and zeros is like this. Up here is the top, that is y minus 1. This entire section here is y minus 1. This entire section here is y plus 1. This entire row here is x plus 1. This entire row here is x minus 1. And that way we can get each of the neighbors of this 0 right here. And in this function here, we check if we check all the neighbors to kind of like do a counter of how many are alive. And then here are all the checks for the array, and we check each of the neighbors if they're alive, and if they're alive, then we do a bunch of if statements regarding whether the live cells remain alive or if the live cells go extinct, and whether a dead cell becomes alive or whether it remains dead. Then we push that all to a new array, and we set the initial array to the new one. And we print it out, and we get game of life. Just kind of like our previous rules, It's somewhat easily implementable, but this uses 2D instead of the one-dimensional one-dimensional kind of grid. So you don't get stuff like triangles. If I were to compile my previous programs, we don't get all this stuff instantly. This is something that could go on forever downward. In Game of Life, it goes on forever, just like in that grid. And this is a cool little example of Game of Life that I wrote. And as you can see, it works perfectly. These two are going to collide and kind of like explode each other. And as you can see here, we have a bunch of types of instances here. We got like a blinker, I think that's called. Down here we have like a block. We got loaves. Apparently we made a beehive. And a boat. So that's all I really wanted to show for now. I made Game of Life in my language. It's pretty cool. It makes a cool little image like this. As you can see, it's the same each time, just because we're using these rules. They're going to explode each other, which is honestly quite cool if I do say so myself. But the reason why I did this is because it is Turing complete and can simulate a universal constructor or any other Turing machine. And there's actually a cool video on YouTube. Game of Life in Game of Life. Life in Life is what it's called. And as you can see here, this entire thing is Game of Life, but what it's doing is it's simulating Game of Life in Game of Life. And apparently this guy made a video, Life in Life in Life. I'm curious what this is. So here we zoom out to the second iteration of Game of Life. Oh, okay, so it switches over to like show that this is technically possible. But yeah, so technically I can simulate anything that I want in this, and it'll work. So yeah, have a good day.